Hey Stanford, today we're going to be learning graph trees for operation of software by large multimodal language models. So particularly when you try and get an LLM to operate software, a lot of times some of the more subtle symbols it's not able to understand. And another problem is that it has no motor control system for interacting with the mouse and keyboard in real time and responding to um, mistakes and uh, understanding what it knows and seeking resources for what it doesn't know. Um, you can see that kind of like a first pass on an approach you can take to providing LLMs the capability to use Blender is simply to contour, run a contour bounding on everything, and then go ahead and just hover the mouse over all of the contours. And particularly in Blender, there will be a tooltip that pops up over some of the objects. And what we can do is correlate contour symbols to the tooltip text. And in that way, when the LLM is searching for a capability, it can search based on text and then find that symbol on the screen by mapping a cache of text describing what a symbol does to the image of the symbol to a image similarity search hierarchy in which it can find a symbol. Now there are a few things to keep in mind here. One is that sometimes there are duplicate symbols on the screen, and there are different formats in which there are duplicate symbols. Sometimes you can see, like here, there are rows and columns of symbols, and these are a good sign of how we can extract inverse prefabs. And you also might realize that sometimes some of the symbols in the inverse prefabs are going to have different states. For example, visible or not visible, rendered or not rendered. So we need to basically be extracting the statefulness of symbolic representations in user interface. Now, there's also something else, which is that how can we go from something which is non editing of the user interface subgraph to something that is. And so what I mean by that is once we start automatically clicking on stuff, how do we frame that within the context of graph tree learning for pathfinding? So once we start clicking on stuff, whole subgraphs of the scene are going to be modified, and sometimes they're going to be modified in a dynamic way, which is depending on the content which is loaded into the software, and other times they will be modified in a static way where the behavior of the software is fixed. And a good example in Blender is View 3D mode. When we start clicking and dragging in that mode, there's really non-deterministic contour behavior because it depends on what's in the scene, whereas something like the properties has a very deterministic behavior and very predictable. Now there's various degrees of predictability of what will happen in the user interface in different area and region subgraphs. So something to consider is that some symbols are going to be dynamic, like this orbit gizmo here, and so we need to ground them in spatial relation to other symbols on the page so that we can identify where they are, even though they are changing visually. another thing is that that's it.